Design a search autocomplete system for a search engine. Users may input a sentence, at least one word, and end with a special character or hash. So each sentence should have at least one word and it will end with a special character hash. So we are given a string array sentences and an integer array times, both of length n, where sentences I is previously typed sentence and times I is the corresponding number of times the sentences were typed. For each input character except hash, we have to return the top 3 historical hot sentences that have the same prefix as the part of the sentence already typed. Alright, here are the specific rules. The hot degree for a sentence is defined as the number of times a user typed the exactly same sentence before. The return top 3 hot sentences should be sorted by hot degree. Like the first is the hottest one. If several sentences have the same hot degree, use ASCII code order, smaller one appears first. If less than 3 hot sentences exist, return as many as you can. When the input is a special character, the hash in this case, it means the sentence ends. In this case, you need to return an empty list. Alright, so implement the autocomplete system. This is the class we have to implement, and it takes 1 sentences and 1 times. So these are both are n length, and for each length basically it means this sentence has been searched this many times previously. Now the one input, this is the input call we are making with the character C. This indicates the user typed the character C. Alright, returns an empty character if C is hash and stores the inputted sentence in the system. If it is this character is not hash, then we are just keep typing, and for each typed sentence, for each typed character we need to get the top 3 hottest sentence for each character. And if it is a hash, then we need to store the currently typed sentence. Returns the top 3 historical hot sentences that have the same prefix as part of the sentence already typed. If there are fewer than 3 matches, return them null. Okay, fine. It's the same thing they're saying. One input is autocomplete system. This is initializing with this 2 array. This is I love you, I land, I Roman, I love Leetcode. This is the sentence array, and this is the times array. Like I love you was searched 5 times, I land 3 times, I Roman and I love Leetcode 2 times each. Next we are having the input calls. What we are importing? First we are inputting I, then a space, then a, then hash. So we are having this autocomplete system. This is where we are initializing the system. We got 1 sentences list and 1 times list. In sentences list, I have few sentences with their corresponding frequencies. Like I love you has been searched 5 times previously. Island has been searched 3 times. Similarly, this Iron Man and I love Leetcode has been searched 2 times. So with this, we are initializing our system. Then we are getting inputs one after another. Like first input we got is I. So every words currently in our system is starting with I. And from there we have to return only 3 of them based on the search frequency. So I love you, this has been searched 5 times. This will definitely be in our system, in our result. Then is island. Island has been searched 3 times. That will be in our result. Then we have Iron Man and I love Leetcode. Both has been searched 2 times. Which one should I which one should I output? We'll see here. After I here coming is space, and after I here is R. Space has a ASCII value of 32, but R has a ASCII value of, I guess, 114 or something. So this one will come first. So whenever there is a tie, we'll sort based on the ASCII value. So our result will be I love you, I learned, and I love Leetcode for I. Next input we are getting is a space. We already had I and we are getting a space. So how many sentences here is starting with I space? This one and this one. I love you and I love Leetcode. So that will be our result. So we don't even have 3 results to output. So whatever, like we just had 2, we'll just output 2. Next we got A. I space we already got, then we got A. Is there any sentence that is starting with I space A? No, right? So we'll return empty list. Next we got a hash. So we already got I space A and then we got a hash. So whenever we are getting a hash, as per the question statement, we have to store the currently searched sentence. Like I space A, that will be the sentence, and that we have to store in our system. I mean, we don't yet know how we are going to store the system, but at least we have to store this I space A in the system, so that next time when we will be searching I space A, we should get some result. So whenever search by prefix comes into picture, the first data structure that comes to our mind is trie. So here also we'll create a trie for this problem. So our first sentence we have is I love you. So we'll create the TrieNodes for this sentence. So here we have this root TrieNode. Then I'm creating a node for I, then space, then love, space, you. Next we have island. So we already have this I love you, and already I we have in our TrieNode. So we'll just add the nodes for SLAND. Next we have I Roman. Similarly we have created nodes for I Roman. Next we have I love Leetcode. So I love space. Still here we already have the nodes. We have to create this nodes extra for Leetcode. So now the question comes to our mind is, we can create the trie like that and we can store the searched sentences in our trie. But will that be enough? We need to store something else as well. So for each node we need to store like what all sentences has been searched with this prefix. Like if we consider this I node, there are 4 sentences that has been searched with the prefix I. So at each node, TrieNode, we need to store what all sentences has been searched starting with that prefix. But again, will that be enough? No, right? Because we have the frequencies in picture, right? So I love you was searched 5 times, island was 3 times, I love Leetcode is 2, I Roman is 2 times. So we need to store the frequency. So number of times those sentences has been searched, that also needs to be stored. So we in each node, let's say we are having one dictionary or one map where we will be storing each of the sentences with their frequencies. This way, let's say when your user is typing hash, that means we have to store the currently running prefix to our system. How will we store it? We'll store this like this, I space, and then we need a extra node for A. Just because we added this I space A, in our I node, there is one more element added, like I space A, that has been searched with frequency 1. So just to clarify if your understanding is correct, so for I prefix we had those characters. Now let's see for I space love space, this prefix, what all sentences will be storing. So we'll go till I love space here, we see this has been searched till you. We have sentences I love you and I love Leetcode. These two sentences. So these two sentences will be stored at this node. Like this has been searched for 5 times and this has been searched for 2 times. So in that way, when we have to return like top 5 element, top 5 searched sentences for a particular prefix, like here in case like I space love space. So for this, if this is the prefix, then we can just take this frequency map and we can just return the top 5 sentences from there. Sorry, top 3 sentences from there. Now let's see the code. So first we'll be creating one TrieNode. Let's create a TrieNode. And this TrieNode will have a set of children. This is a dictionary because for each character we'll assign one TrieNode for that character. And then we have a sentences map, right? Let's call it sentences only, or you can call it frequency, sentence frequency map or something. So this is the TrieNode we have, and let's define one insert function inside TrieNode only. You can create this insert function here in autocomplete system as well, but I'm creating it here. This is the insert, and here we'll take one sentence and one frequency, the number of times. Let's take it, call it frequency only, and the number of times this sentence has been searched. Now my current node is this node only. From this node I will be starting the insert. So what we'll do, we'll go through the sentence, each character at a time. For character in sentence, what we'll do, we'll see if character not in this children of this current node. That means we have to create the children node, right? So what we'll do, current dot children of character is, we have to create a different TrieNode for that character, right? And then we are moving the current pointer to that children, right? So that's for moving through the sentences characters and inserting in the trie. One more thing we have to do here is, for each of this node we have to add the sentences as well, right? For current dot sentences dot sentence. So this sentence, this is the current node. Let's say we are inserting I love. Let's say we are inserting I first. So for I, this is the ith node that we created, right? So first, and initially we didn't have any node for I. We created that node. Then we moved to that I node here. So that for that I node we have to store this sentence, whatever sentence currently we are inserting, and with that frequency, that will be, let's say this sentence may already be present in this dictionary, otherwise we are inserting a new one, right? So we can call it cur dot sentences dot get sentence 0. This is the default value if it is not present, and then plus this frequency, that many time it is been searched. So that is basically when we are initially storing the sentences that are given to us, like these sentences, right, those will have some frequency 5322, that number we are adding here. So later when we'll add this I space A, right, later, so that time it will be inserted with just the frequency 1 because that is a new one. But anyway, whatever, if it is present, we'll add the frequency, otherwise we'll just add with the 1 frequency. That's it for the TrieNode. Next we have to initialize our system. How do we do that? We will have a, let's call it try, and that is we are creating a root node for our try. Next, for each of these sentences and times, those we have to insert in our system, right? So for sentence time in zip, sentences and times, will insert it into our try root. Try dot insert sentence and times. Not times, it will be time, right? So this is the sentence and this is the time that we are inserting for each of the sentence. Next, fine. Next we have to do one more thing. After we have inserted everything, then we have to go to the input, like we have to process the inputs, right? But every time we are getting one input, we are storing it somewhere, because when I was inserting I, we are getting the result for I, but next we are inserting just space. That time we need to store the I somewhere, right? So we need a pointer. Let's say self.current pointer. So that initially will be in TrieNode, assigned to TrieNode. So when we'll first get I, the car will move to I. Next we'll get a space, the car will again move to cell I space, and so on. Also we have to store the element, store the search sentence when user will input a hash, right? So which one we should insert? Like we have to store the prefix as well, because here we are just storing the current pointer, right? So that when we get a new character, we know from which node we have to search again, right? We have already searched till this prefix, and from there I have to go to a different character. This is for this pointer purpose, but we need to store the prefix as well. Let's say the prefix initially is empty. So that's it for our initialization. Then we'll go to the input. So the input can be two things, right? Input can be either hash or it can be the normal character. So let's consider these two cases. If character this C is hash, then what we'll do, we have to store the currently running prefix. We'll populate the prefix when we'll move, right? Then we have to store the prefix. But before going there, let's go to the other part. Let's say if we are inserting some other character, first we're inserting I, then space, then love, and so on. So what we'll do, self dot prefix plus equals to C, like we are just adding that character to our current prefix, and then we'll move to that prefix node, right? We'll move to that character node from our place. So if self.car, so that is our current pointer, and this character is present in the children of this self.car. In self.car.children, then what we'll do is self.car will be self.car.children C, right? We just move to that character. Then what we can return, we have to return our self.card is changed. Let's say if initially we are inserted I, so we'll move to that I node. So then for I node, we have to get the top 3 sentences stored in that node. So let's say we'll have a helper function. I'm not going into that helper function now. We can call it like get top 3, right? And I will just come to that later, and it will take one now. Let's say I'll just take the sentence frequency map, right? So sentence map that I will taking, and it will return some it will return the top 3 searched sentences. We'll implement that later, but I'll just return that here. Return get top 3 self dot get top 3, and that will be self dot car. This is the current node pointer we have, and the sentences stored in that node, right? So this is basic things we have to do. There is a corner case here. If that node is not present, if I is not present in our system, and let's say we are someone is searching for mango, so that M is not present in our system. Like when we from the root we will search for M, that is not present, right? What we will do in that case? We have to return empty, right? We don't have any result for that. So basically, from if we don't have that prefix, we cannot do further search as well. If we don't have M, we don't have MA. So what we can do is we can just, this is a simple question. Basically, for complexity, if we want to add complexity, we can handle it later differently. But let's say self.car will become none, because that is invalid input basically for this question, and then we can return an empty list. Now let's say if we have searched M, right? So we got the curve will become none, right? So then in that case, after M, if we are inserting A, if we are just inputting A, it will come here, then it will check the self.car. This is not present only, right? It is not, it will again go to else. So sorted. Now come to the hash part. When you are getting a hash, our prefix is already populated. We have to store the prefix in our system. How we will store it? We have this self.trie, so where we have to insert this self.prefix with frequency 1, right? So this is with we are not storing with frequency 1. Maybe we are searching the same prefix again and again. In that case, we'll just increase the frequency by 1, right? So plus frequency. So that's it. Now after storing, my prefix will have to change, right? My prefix will be empty, right? If you want to process it for next time, like if you want to process a different prefix, then what will be my current pointer? That also have to change, right? Because of my current has reached till the end of the prefix. So self.car will be self.trie. It will start again from the trie root, right? And what will return in this case? Here we are not returning anything. So if when the user is inputting hash, we are not we are just storing the data current prefix, but we are not returning anything. We are returning empty. Okay, so now one thing I have missed is this get top 3. How do we implement this get top 3? Basically, we have a sentences map that will have the sentences and the frequencies. So we can just sort this map and we can just return the top 3. Like sentences is basically sentence 1. It is stored as sentence 1. Frequency 1, and so on, right? What we'll do, we'll convert it in this way. We'll store this frequency 1, sentence 1, and that way frequency 2, sentence 2. In this way, if we just store it, and then we can just take the top 3. That is one solution. but we do need to sort the whole array. Or we can use a heap based solution, right? So what we'll do is, let's take one list. I'm calling it heap, you can call it anything. So what kind of heap do we need? We need a max heap or main heap. We can use both, but for our particular solution it will be easier if we take a max heap, and we'll just add the sentences with their frequencies in this format, like frequency and then sentence, so that then we'll heapify that heap, and after heapify will run in order of n if there are n sentences at each node. So then we'll sort, basically we'll get the output in maximum sorted order, right, based on the frequency. And if there is a trie, that will be sorted based on the sentence, like graphical order of the sentence that we discussed earlier. So like space had ASCII value 32 and some other characters had around 100, 114 or 15. So space will come first. So this kind of search. Okay, first what we'll do is, for sentence and frequency in sentence map.items, right, we got the sentence map.items. We have to put it in this heap. It's basically nothing, we're just doing an simple append, and what we are appending, this frequency and the sentence. Next what we are doing is, we will be doing the heapify, heapq.heapify and then heap. So this is will run in order of n. Next we need the output, right? So this is the output we'll store here, and we'll just, okay, I think I made one mistake. So we need this is a max-heap. So Python doesn't have a max-heap concept inbuilt, so we can store the frequencies in negative way, so that we'll just store the negative of the frequencies. Now for I in range, we need top three requests, just top three sentences, right? So in range 3, or it will be minimum of 3 or length of heap. Basically, if we don't even have 3 sentences, then we'll return how many we have, right? Then output dot append, what we need, we will be popping from the heap the top 3, right? At the top we'll have the maximum element that will pop, then again some other will come at the top, so then again that will pop. So we'll just strip here at heapq dot heap pop heap, and what will be the element? That will be the frequency and the sentence, right? But we don't need the frequency, we just need the sentence. So this is 1. So now we can just return the output. So that's pretty much it. Let's run it. Yes, this works. Let's submit this. Yeah, this is pretty efficient. What will be the complexity? Any guess? Oh, it can't. So the complexity we'll try to assume. I'm not complicating things here. Consider roughly we have n sentences, the initial sentences, and we are adding new sentences, right? So roughly we have n sentences, and S is the max length of any sentence. H is max elements in a heap. Heap is basically where we are storing the sentences for a particular node, right? So max heap size is H that we are considering. So that can be based on worst case scenarios. Like best case scenarios will be all the sentences share some prefixes. Worst case scenario will be no sentences share any prefix. So there will be lots of nodes created for that case. But in any case, like let's consider the max elements in a heap is H. What will be the complexity for insert? Order of S for each sentence, because we have at max S length of characters, and for total it will be order of NS. What will be the complexity for getting top 3 such sentence? That will be order of H, because we are doing a heapify that runs in order of n time. The heap size is h, so it will be order of h. Then we are getting the top 3 elements, but that is just a order of 1 operation. What is the complexity of input C? Not any other hash, not hash, any other character. So for input C, we are adding into the prefix. We are just moving to the particular node. The current TrieNode is moving to its proper children. So with this two are order of 1 operation. Then we have order of h, that is for get top 3. What is the complexity for inserting a hash, inputting a hash? When you get putting a hash, then whatever the heap prefix we have, that we are storing in the trie, right? So max length of any sentence will be s, so that will be order of s. Now what is the space complexity? It will be order of ns, because we have n sentence roughly and s is the max length of any sentence. So yeah, thank you so much.